Okay. Yesterday we discussed about the three main terms, which are
Yes, ma'am.
yes, which are artificial intelligence, machine learning, and deep learning. Artificial intelligence is a broader umbrella which consists of machine learning, and a specialized type of machine learning is called deep learning. Artificial intelligence is nothing but making machines act like humans, as we discussed it before. And machine learning is something which learns from data and gives us the output. So basically,
Yes,
a part of artificial intelligence, which is like acting like humans, where it consists of thinking, learning, and making decisions. Machine learning will do the learning part from the data. And again, one more specialized thing: if the data is too much heavy, like 2 lakhs of data sets or examples or something like that, if it is there, then deep learning will be used. Here, neural networks will be introduced. This is all we discussed in yesterday's class, isn't it?
yes, ma'am.
Yeah, I want you to understand the difference between the traditional programming and machine learning as well. In traditional programming, we give the logic, but in uh, machine learning, our model or algorithm learns the logic by itself by finding the patterns. Uh, uh, by giving the, like, how should I say, if we give the data and in both input and output, it finds the patterns between both of them and it understands the logics. That is how it is going to learn. So the main difference is like the logic and traditional programming is given by us, and machine learning, it learns by itself.
Ma'am.
Now deep learning, whenever these neural networks are introduced, it's deep learning. It has been introduced to work with large and unstructured data. You will be knowing what are different types of data in the next module, a third module probably. And we also discussed some. Hello.
Yes, ma'am.
Did my voice get altered or something just before?
No, ma'am.
Okay, okay,
It's clear.
okay. Okay, now. So we revised what we dealt yesterday. Mm, Now let us go through machine learning cycle. So let us complete this today because it is good if we complete this in one shot. Now, what is machine learning life cycle? In the like this is like how we are going to solve a problem using machine learning. Problem in the sense, you can say it like how to predict the house. We already saw many examples in the previous slides, like predicting the house prices, detecting spam emails, fast
Yes,
tagging. So this is one a problem statement or something like that. Now, how are we going to solve the problem? It has every process has some, like, how should I say? This machine learning life cycle has a process, predefined steps. If we follow on these steps, we'll be able to solve that. Now, let us start with the first one, problem definition, where the problem, each of the step will be clearly explained in the further slides. So just go through this. I made it too many, but here nothing, like 10 of them. To make it clear, problem definition, like here the understanding of problem, what is it, why is it, what do we want, everything will be done, everything will be understood here. It's like brainstorming. It doesn't need any tools, it needs what is the problem that we are going to solve. And data collection, what is the data required, the planning will be done in the problem definition. Data collection, what we require to solve the problem. Data cleaning, after getting all the required data, we clean and pre-process them. And EDA is like finding patterns, like collecting the exact data that will be used by our algorithm, machine learning algorithm. Feature engineering is like converting, or do not worry if you it is too much for you. We'll be discussing each one of the step in the further slides. It is just like introduction of every step. uh, Feature
okay,
engineering
ma'am.
and selection is like, once we get the data and understand the data till fourth point, the data. And after the fifth step, we'll be converting that data such that our model algorithm here, selection in the sense, will here model selection will be done according to our data, according to what we want, according to the requirement, according to the problem. A model, I mean machine learning algorithm, will be selected, like linear regression, decision tree, or something or the other based on the requirement. uh, to fit the data into that, our data will be engineered in the sense, it will be uh, the data will be cut, or like how should I say, data will be made in a such a way that it will fit into this algorithm. After that, we'll train this algorithm and then we'll test it. If we find any shortcomings, we'll tune it. That is what tuning means. After we train and test, when it is ready, we deploy it in some or the other platform. Deploying in the sense, uh, how should I put into, like we use a platform or a software to run it. Like we have web pages, no? That's deployment.
Yes.
Like how should I put into, now we have a Gmail, Gmail or Google something. It is deployed in a, it is after training and testing, it will be shown this is how things are done. And it is for like real use till 8 point.
Executing.
Yes, till are you not able to hear my voice?
Yeah, ma'am, I can hear, ma'am.
Okay. And till 8th point, nothing sort of real world usage, I mean real world cases has not been introduced to our model. From ninth, in the model deployment, real data will be used. I mean it will be used. After ninth, it will be used by the users, like how we use Google, how we use Gmail, how we use our apps or something like that. That is model deployment. We'll make our total project into like user friendly. That is what model deployment, that's all comes under model deployment stage. Monitoring and maintenance, like user might get some problems. The user in the sense, the one who is using our product or something like that. So he might get some problems, or else he might need something, or else after sort of some months or something like that, our model might need some changes. Everything will be done in the 10th step. So what I have written here, just like building a house, you need raw materials like data, process them, cleaning, construct, modeling, and then inspect and move in, evaluate and deploy. Like this, consider this is just an analogy to make you understand what is life cycle, machine learning life cycle is all about. Now, with the introduction is done, let us move to what is problem definition. Have written it clearly here. Like once you see this, you're going to with the real world example as well. Now here, what is it? This is the stage where we define what we are trying to solve with machine learning. Like here in a company or something like that, usually how things work is like a client comes to your company. Suppose you are a service based company. That is in the sense, the company you have for example, Mansa, just think that you are a company which offers to other companies, like offer service, like in the sense you offer like machine learning services to the other companies. Think it of it like that. Now just let us take an example. One company take to you, big basket, like you know that it's a grocery store or something like that, online grocery store or something like that. So it came that we need a machine learning model or something to predict the prices of this or something, or like to predict the prices, or to understand what our customers are frequently buying or something like that. They'll come up with one problem. Now you in this statement, you have to understand what they are asking clearly, because here we deal with the technology and they come with the business problem solution. So this step is the combination. Here we need the business knowledge, I mean the domain knowledge, whatever we are dealing with. If we see this example, we want to predict house prices based on location, size and amenities. Definitely, as we are into the technology, we might not be knowing the recent trends, how the house prices are, or else according to what characteristics like location, size or amenities, how they are going to affect our house prices. Definitely we won't be having that domain knowledge. So the main trait of a machine learning engineer, or anyone who works with this kinds of problem, need to have some domain knowledge. How will we get that domain knowledge? By working on some projects, real life projects. Right now, till we get a job or something like that, we as a students or learners, we are going to try with some just examples in the net or something like that. But when you become a really professional machine learning engineer or something like that, then you'll get to know the real life examples, you'll work on projects. That is how you're going to get the domain knowledge. So in this step, you need domain knowledge to understand what do the customer or the client wants from you. Here we want to predict houses prices based on location, size, and amenities. Amenities in the sense necessities around the the park. That location might have a park which have definitely school or something. It will have g- greater house price than the house which doesn't have all those things like that. Now you have to discuss it with the client, and you have to have the domain knowledge. Along with, you need to get a clarity on the what really the problem is. That is what is all about this thing. So what happens, you identify the problem clearly. What do you want the model to do? Yes, what should model, in the sense the model you are going to build, like what does our model is going to do? Predict the house prices. This is the model we are going to build. Assume that this is the example we are working on this to understand machine learning life cycle. So first, in the step, we identify the problem clearly. What does the client want our model to do, and who will use it? And it also depends. Now the company is using it, so you have to make it according to the company needs. If the customer, the users or else the normal people are using it, you have to make it in another way. So what do they need? According to that, your product changes, right? So that's how you need to have a clear picture here. Based on all this clear picture will be coming based on the domain knowledge and the technical knowledge you have to know about the algorithms you are going to use. And you also have to know what does the problem actually want. Now here's it. After all these brainstorming sessions, and after you understand the problem statement clearly, you're going to have this simple thing, like what is the goal? In simple words, predict house prices. Who are going to need this? Assume that clients are real estate agents, buyers, and sellers. These are the target. These are To these people we are going to give this model. These people are going to use our model. So our target customers, or whatever you say, the people who are going to use our model are real estate agents, buyers, sellers. And what is our goal? Predict house prices. The models needs to predict the house prices. Our model will be used by real estate agents, buyers, and sellers. And what will be the input of our model? Location, size, and amenities. What would be the output? The price. Purpose is like, what is the purpose of all this building that model? Set realistic expectations and make data driven decisions. If we have this model, we can know easily, right? Even if the person who is not having any domain knowledge or the knowledge or about the trends or something, he will, with using our model, he'll be able to predict the price, right? That is the whole purpose of this. So this is what the use of this problem statement stage. Why is it important? A well-defined problem guides every step that follows. Without a clear goal, you're just mixing ingredients blindly. I hope you understand what happens in this problem statement session. So basically, we'll know who we are going to make the model for, and what kind of a model we are making, and what is the outcome we want from our model. So when you get confused about all this, just read the example well. Okay. After that, let us move to data collection. Now we know that what to do and why to do it. Now we have to know, like, what should we need, right? We know what we are going to do. Now we are in the stage where we need something to do it. Data collection is gathering raw data that is needed to build the machine learning model. Yes, we need to gather data. How do we gather data? What happened? How do we gather data? Collecting data from real estate websites about houses prices, like anything. If you search, if you are like, how should I say, if you go to the internet or search some things, we'll get some, I mean, basically they have some specified websites or specified data websites or something like that. So in that they might be in CSV form or JSON. You know the CSV, no, Excel sheets.
Yes, ma'am.
Yeah, like that, JSON forms, in any form data will be present. That is raw data without any like it is like not structured or unstructured. It is just raw data from the core. It doesn't have anything. We need to clean it and we need to make it useful. Like, I mean, to put into short words, we need to
Okay.
clean the mud around it and we need to make it uh, usable. That is all. And what happens in this data collection, we'll pull data from sources like CSVs, databases, using, like, this is called web scraping, actually. APIs in the sense, just assume that some website, sensors in the sense, if we don't have any data, suppose I'm getting out of the context, suppose we need we want to predict what is going to be our crop yield. Suppose we got some problem statement from agriculture sector client, and he wants to know when crop yield, how much he's going to get the crop yield. I mean, how much the crop he's going to get as after the harvest, based upon the weather conditions, pesticides he used, and the nature of that crop. We are going to decide it. To sense all that, definitely we need some knowledge about the crop, and as well we'll put some sensors like humidity sensor and temperature sensors. Will collect the data to understand the weather. With using all this, we'll make the data and then we'll use it for model building and something like that. That's an another issue. So sensors, I just wanted to explain, like, we can collect the data and using sensors as well. It depends on the problem statement. And why is it important? The quality and quantity of data determines how well your model performs. Yes, the more the data you have, the better your model performs, because it understood the patterns from large set of examples. So the quantity is really important. Quality is like, we need a clean data. I mean, clean data and a realistic data, true data, without any flaws or loopholes, to make our model perform better. So the only goal here is to, like, make a model which predicts the house prices, right? For that we need a good data. Now we understood what the data collection is all about. Now let us see an example. See what we are going to do is, I just took a CSV file. Okay, now we collected a raw data in the sense, we have here an area, like this is like related to Hyderabad, and we have the size, I mean the house size, bedrooms, what do I mean, how many bedrooms does it have, amenities like parking, lift, gym, security, and the price. This is like historical data based on the recent trends or something like that. We have this. So this is what we collected from websites or something, already existing platforms or something like that. We collected. This is a sample of a from whole data set. Here, how many data samples do we have? Sample in the sense, one row. Okay. Oh, I'm very
Okay,
sorry.
ma'am.
Remember this sample. It's better if you write down also. A row in a data set is called a sample, data sample, or a data example or something like that. And area, size, bedroom, amenities, price, all the columns are called features. Features in the sense, they are going to affect our model in that is what features mean. So this is one sample. Oh, why is it ending? Oh, I'm very sorry.
No, ma'am.
Okay. uh Manasa, we'll take a little 2 minutes break after this. We'll continue in another meeting, okay? Because this meeting is already set time for, in 10 minutes, this meeting will be over. We'll again start with another meeting. We'll take some 20 minutes or something. We'll close the session. Is that okay?
Okay, ma'am.
Okay. Let us, no worries about that. I can deal with that. You just concentrate on the subject. So one row is called a sample. I mean, one data example. The area, and one column is like area, size, bedroom, amenities, price, and these things are called features. Now we got
Okay.
to know I mean, we understood what is problem statement phase, data collection phase.
Yes, ma'am.
Now we'll be going to data cleaning and pre-processing. What is data cleaning and pre-processing? Now we got the raw data. Definitely raw data, if we see here, there are so many things. Parking and lift and BHK. Always remember that any machine learning model or any computer does not understand these words. I mean, BHK or something like that. It will convert all of this into numbers at the finest. In the lowest level, a computer or any machine will only understand binary digits 0 and 1. Every letter we press or everything will have a binary code for it. For example, 2 has a binary code. You know, no 1010, something like that. 001 for 2, binary code. Yeah, for 3,
Yes,
for
ma'am.
2. So computer only knows zeros and ones. You remember that? So everything will be converted. We'll make this data, so clean that, so adjustable that our computer, our model does not feel any uh, problem to understand this, so that it will learn properly. So that is what data cleaning is all about. Making, what is it, making the data clean, usable by handling missing values. What if our data doesn't have these bedrooms thing? We don't have any ways to collect the data, so what are we going to do? That's a problem, right? There is a no value, so that is a problem. So how do we treat, how do we handle those missing values? What if here in the amenities we got some number, how we are going to deal that? And formatting in the sense, for formatting data, formatting in the sense, just assume that here the price is 5 rupees. Definitely something is wrong with this, no 5. Definitely it won't be 5 rupees, no matter what is the circumstance. Definitely it is not going to be 5, so it is not a valid. So something wrong has been, so how are we going to handle wrong values? And formatting, let us assume that here it is in dollars and it is in rupees. Definitely these two are not in the same units, so we have to make, in a column everything has to be in the same unit, such that it will give the model, I mean it makes easy for the model to understand things. So that is what formatting does, converting everything in the column into one unit. That is what formatting means. Normalizing, just normalizing in the sense, see, for a computer to understand 65 lakhs 85, the maths here, do the math here, like assume that you multiply 253 and 253, it is a bigger number. Okay, the computer can do it. Assume like a multiplication of 6 digit number and 6 digit number. Of course computer, our model can do it, but it takes some time, no? What do we do is we normalize it. I mean, we convert that same thing into uh, something between 0 to 10. At 0 to 10, any number can be represented from 0 to 10. You just assume that there is a method like that. So this six digit number will be given a position somewhere from this 0 to 10, and another 6 digit number will also be given the position from 0 to 10. So now we have two single digits. It is easy to work with them, no? Instead of working with 6 digit numbers, it is really easy to work with a single digit number. That is what normalizing is all about, like making the multiplication, making the maths easy for the computer. Missing values, I already explained all the things to you. What happens in this data cleaning and pre-processing this data? We remove duplicates. For example, just assume that this data set has this data sample, this Kukatpalli data sample, like two times. Uh, Two times it's okay. It's fine as long as. But what it is repeating for 10 times, and we don't know how many data samples are repeating. What happens if we have repeated data? I mean, same samples. What happens is that the data will become more like, model will learn easier in like 10,000 samples. But if we give 20,000 samples having the same data, it definitely is going to take time, which is not efficient at all. That's why it is efficient to, it is important to remove duplicates and handling missing values. So if any missing value is there, how are we going to fill that gap? Converting text into numbers. So I already told you, computers can't understand text. We have some methods to convert text into numbers as well, and that numbers will again, by computer itself will convert them into binary codes. That's not a problem. And why is it important? Dirty or inconsistent data. Inconsistent data, I'll define the term. Please remember this inconsistent data word. When you get into it, you will be knowing what is inconsistent data. But right now, just uh, assume that inconsistent data is something which will be dealt in the data cleaning process. What will this do? Dirty or inconsistent data can spoil your results, just like dirty vegetables can ruin your dish. Yes, just like that, they are going to affect. If we have missing values, the accuracy will be missed. I mean, price of an house can't be calculated if we don't have